All right, let's open up the terminal and get into one of the most fundamental topics in networking. In this lesson, we're going to unpack MAC addresses, what they actually are, and more importantly, how switches use them to learn the layout of your network and forward traffic intelligently. By the end, that classic show MAC address table command is going to make complete sense. So let's start with the address itself. A MAC address is 48 bits, 12 hex digits, burned right into the network interface at the factory, and it's how devices identify each other at layer 2, inside the local network. Now, here's the neat part. That address is split in two. The first half, the OUI, tells you who manufactured the card, Cisco, Intel, Apple, and the second half is a unique device identifier assigned by that vendor. Put them together, and you get a globally unique hardware address. So now that we know what a MAC address looks like, how does a switch actually learn them? It boots up knowing absolutely nothing, an empty table. Then a frame arrives and the switch does something clever. It looks at the source MAC and notes which port that frame came in on. That pairing gets recorded in the MAC address table. Then it checks the destination. If it knows where that MAC lives, it sends the frame out that one port. If it doesn't, it floods every port and waits to learn. Learn from source, forward by destination. And here's how we actually peek inside that table. The command show MAC address table lets you see exactly what the switch has learned. 3 devices in VLAN 1, each mapped to its own gigabit port. SysAdmin, GIA02, GIA03. Notice, the type column says dynamic, meaning the switch picked these up on its own from incoming traffic. And if a device stays quiet for about 5 minutes, its entry ages out and disappears, keeping the table fresh. Now that the switch has its table, every incoming frame triggers one of 3 decisions. If the destination MAC is in the table, it forwards out the one correct port, nothing more. If the destination is unknown, or it's a broadcast, it floods out every port except the one it came in on. And if the destination happens to live on the same port as the source, it filters, just drops the frame because there's nothing to do. So remember, unknown unicast and broadcast both get flooded. And that's how a switch builds its world at layer 2. Learn from source, forward by destination. But there's still a missing link. How does a device figure out the MAC address for a given IP in the first place? That's exactly where we're heading next, with ARP, the protocol that ties IP addresses to MAC addresses. If this clicked for you, hit subscribe and turn on notifications, and I'll see you in the next lesson.